Hello dear students, in the last video we have seen how we can convert any decimal number into any other number system. Okay, but the decimal number which we have taken in the last video was the whole number or was the integer number. In this video we are going to see how we can convert any fractional decimal into binary number. What do you mean by fractional decimal? Like 15 is the integer number or the whole number, so I can convert that into binary by dable method or divide by 2 method, which we have seen earlier. But if I am having 15.64 this decimal number, so how I can convert this decimal number into binary? I can write this 15.64 this number as 15 plus 0.64, right? So for this integer part, we know the process. We follow the dable method, which we have seen in detail in last lecture. So I am directly writing the binary equivalent for this. For 15, it will be 1, 1, 1, 1. Okay, you can follow the last video for this conversion. So this is the binary equivalent for this decimal number. Now, how I can convert this 0.64 into binary? So for 0.64, I'll write this number as it is. Then I have to multiply that number by 2. Okay. So what I'll get is 1.28. So this part, the number after this decimal point, that I will write as a carry. So I'll write 1 as a carry. And the rest part, that is 0.28, I will write here. Okay, then this part, this number 0.28, I'll again multiply that number by 2. I'll get 0.56. Now in this case, the carry part is 0, so I'll write it here, and the remaining part is, this is 0.56 only. So I'll take this number 0.56, I'll write it here, and again I multiply that number by 2. So for 3 times or 4 times we can have the same steps. So I'll get here 1.12. So again the carry will be 1 and the rest number is 0.12. Okay. So 0.12 again I'll multiply that by 2. I'll get 0.24. Now in this case the carry is 0. Okay, so the fractional part we have to keep on multiplying by 2 and we have to write the carry part here. And the final step is we have to go from top to bottom. For integer part, we need to go from bottom to top. For the fractional part, we have to go from top to bottom. And so what I'll get is, for 0.64 fractional part, I'll get 0.1010. So this way I can write, for the 15 I have the binary equivalent as 1111, and for 0.64 I am getting 0.1010. So this way we can convert any decimal fraction into binary equivalent.